So, are you a software architect or an engineer? Great! Do you try to solve complexity with your software solutions? Well, even better, then can you tell me what is complexity? Most of the professionals cannot answer this question during an interview or a casual conversation that I have with them, and I want to solve that problem with this video. Stay tuned. Before getting into the topic of the complexity, let me take a minute for a quick appreciation for a couple of things that happened since the last video. I've got 6 new subscribers since the last recording, so that's great news. Thank you all who have subscribed to the channel lately and who plan to do so as well. And I've also got several new book readers, and they are telling me that they find the book helpful. I'm glad that this book is finding its place within the industry's professionals and continues to be helpful to bring new talent to the industry. I'm very grateful. Thank you. So what is complexity? Let me start with a story that happened to me a couple of months ago. I was in Seattle, Washington, and I was in the lobby of a hotel where I was working with my laptop. And suddenly 2 gentlemen appeared and sat at the table nearby and started having a conversation. First I was not listening, but then it became very interesting to me because those 2 individuals were describing a major software upgrade that was going to be applied to their work environment. So that was interesting because they were dealing with some complexity and they were trying to understand what the documentation said. They had this documentation open on their laptops and trying to analyze what the various terminologies mentioned in the software documentation meant and how they were going to use it for their daily work. And the terminology sounded complex not only to me but to them as well, because they were making a couple of calls to their support or IT department and asking them what this software is supposed to do, how is it going to operate in such case or in another case. And I suddenly realized that these people are dealing with a complex domain, and also the software is complex as well on top of that. So they're dealing with this double complexity, and that reminded me that the second part of that large layer of complexity, the software complexity, could be narrowed perhaps, but in order to do something about it, first I had to understand what they were talking about. And from the conversation, I was thinking that perhaps these 2 professionals were engineers or something, and they were trying to understand this new environment they had to fix, or maybe to build some new building, or to make some complex decisions about these new structures that they didn't know about. But later on, I realized, surprisingly, that was not the case. And these 2 individuals turned out to be pilots. Yes, those same pilots who operate those planes on which we sit to travel from one city to another or from one country to another. And they were struggling with complexity. And that made me a little bit nervous. I started thinking, well, if it's so complex to even understand what the software is doing, which is on those planes, how are they going to safely operate it or bring passengers from one point to another? And that was the point when I realized that it is a huge responsibility that lays on us, on software engineers, to build software solutions that are not complicating the domain more than it is already. And even more, I was thinking, was it software that was guilty in the troubles of those 2 individuals that I saw at the hotel, or was it the domain alone? And so this story should make you think about what the complexity is, as it did with me. And I think 2 important conclusions come out of the story that you just heard. First conclusion is some domains, and actually most of them, are inherently complex. The complexity level, of course, varies from one domain to another, but there are domains which are extremely complex, such as operating planes. And there are some domains which are inherently simpler, for instance, to record some notes in the notepad. And so that inherent complexity is something that we cannot change unless the domain changes and evolves, but that is not the job of the software engineers or architects, so I will keep that out of the scope. And the second conclusion is that the software that tries to solve those complex domains also adds its own complexity, and those professionals who act in those complex domains have to deal with this additional overhead as well. And that is something that we can resolve actually. And that brings us to the definition of complex software. Complexity in software is an overhead that we add on top of the domain, which is inherent. I know what's happening on the other side of the screen. A lot of people are watching this video and nodding their heads saying, no, we are not adding any complexity to domain. It's the domain that is complex. But believe me, there is overhead that we are adding, and let's discuss one by one some examples from application, solution, and enterprise architecture fields to understand what I mean. Let's start with application architecture. There is such anti-pattern called anemic domains that adds a complexity overhead. A lot of engineers don't even know what this term is, but this is the simplest approach that all of us know. It doesn't require any special education. It just has a name, anemic domain, and it is the way that software is built by engineers who don't know such complex or, let's say, more advanced topics as domain-driven design. Anemic domain is when you design everything as a DTO and state is not encapsulated. It's very easy to implement. And if you Google about anemic domains, you will find out that those are the root causes of the spaghetti code and many other problems that happen to the unmaintainable or complex software. So complexity is caused by anemic domain and other anti-patterns in the application architecture. So that's why I'm claiming that we add an unnecessary overhead to the domain's inherent complexity. How about solution architecture? Well, nowadays, a lot of technologies have emerged and they are so trendy and so popular that it is fancy to use them. So a lot of engineers bring a lot of technologies to the solution architecture landscape and try to use them even if they don't fit well with the domain or the problems that they're trying to solve. For example, I'm sure that you have seen such a solution architecture where a lot of components connected to others represent some technical products, such as, for instance, data lakes, databases, warehouses, messaging, master data management, and so on. So all those technical boxes that you place to build up the entire solution architecture are the overhead. They don't speak about the business language, they're speaking about technology language. And the thing is that it becomes very hard to say how all those technical products are going to serve the business at some point, because their number, influence, impact, and thus negative overhead is a lot on top of the business problems that they try to solve. And that overhead is what makes this entire solution architecture more complex than it could be. And so yes, we add a lot of overhead to solution architectures with these many technical products and even worshipping them, unfortunately. That is done by a lot of engineers and architects. Put the problem first and then apply the technical products to it, not the other way around. And finally, enterprise architecture. This entire discipline has evolved to try to align the business and the technology across the entire enterprises or the organizations. But this discipline itself is so complex that it's practically impossible to fix all the problems that it once planned to solve. So these all problems at the application and solution architecture level cannot be solved with the enterprise architecture because it tries to wrap it in the nice wrap, but as soon as you unwrap it, all the problems are still within. And the enterprise architecture itself needs to become a little bit simpler as a discipline or a science on its own, and then it will be easier to apply it. But to conclude, even the enterprise architecture cannot be very effective due to its own complexity, and so it adds a lot of overhead to the already existing problems. After having said all that, I think we are ready to define what software complexity is. It is the overhead on top of the inherent domain complexity that the software adds, and the software that you build is complex if it's making the domains that it serves harder than it is. Now that we have answered the primary question, I think it's worth answering 2 bonus questions which will deepen your understanding of the complexity in the software engineering and architecture. First question, do the complex sciences and approaches making the software more complex? It depends. A lot of advanced skills and sciences and disciplines are trying to solve the complexity problem. For instance, domain-driven design is trying to align the business and the solution at the application architecture level. So of course it is not making matters worse because it is trying to solve the complexity, although the skill of the DDD or the domain-driven design is complex on its own, but it's trying to fix the complexity problems within the software solutions that you deliver. So no, complex skills and patterns are not making the software more complex. They're making it simpler as long as they are trying to solve the complexities that I described earlier. And now the second question, opposite to the first one. Do simple sciences, approaches, and disciplines make software simpler? In most cases, no. For instance, I already described an anemic domain pattern, which is actually an anti-pattern, which is very easy to master. In fact, we already know about this pattern even without anybody explaining to us what it is. And it's extremely easy to apply this pattern to your solution, but you're complicating the solution because of this anti-pattern. So no, although the pattern is simple, you are making things worse. And with that, let's wrap up the topic of complexity. Thank you for watching. If you enjoyed, you know what to do. And I'll see you next time.